Imagine having a programming language that you constructed that allowed you to create ebooks with images and stories, maybe create videos using Sora or Runway ML. Or how about processing thousands of lines of code using a large language model AI pair programmer like Cursor or Ada? In this video, we're going to use OpenAI's Canvas to see if we can process some programming languages designed just to solve those problems. So let's give a little bit of context before we get started. For a little while now, I've been writing a coding language called KlueLess. The clue is to do less, and the idea is a set of programming languages that interact with large language models. And I've been working on various forms of documentation and examples and the rules around how this coding language works. Now imagine you wanted to create a programming language purely to work out the costs for a cafe in Thailand. Seems like an odd idea, but let's have a look at a programming language that could do just that. So here we have this concept called Kozi Kafe, and within it there's costs that are involved that are in local Thai baht, but we might want to express those costs in US dollars or Australian dollars. And then there's a bunch of settings. What's the coffee shop called? Where's it located? How about the recurring costs that are related to this particular cafe? The coffee shop probably needs an owner, and there's a role that the owner might have, and there may be other people involved in working in the cafe. And as you keep going on, there's investment and estimates for different products, and then the actual costs involved in setting up this particular shop. Now that may seem a little esoteric, so let's drop into a more practical example and look at a tool that I've got that allows me to gather all the files in tree structures or in content structures so that I can use it with AI pair programmers. So in this particular case, it's called Context Gatherer. It gathers files like the requirements documentation, any of the database schema files that are needed, a bunch of use cases and code, but it doesn't include the node modules folder. And if you ran this particular script, the idea is that it would go into the clipboard and it would capture both the tree and the content. Now that little domain-specific language that you just saw is actually backed by a real tool that's designed to gather content trees from different applications, including their content. It allows you to include the files that you want, exclude the files that you don't want, and then format the information either as code or tree structure. Or imagine you want to combine concepts. So here we have a little coding language called build prompt. It gathers different files that you might have on your system, and then using those files, it puts it through a prompt generation process. So here we have the header for the prompt, then each file name that's found from above is included in the prompt, and then it's closed off with the footer. And all of that information might be put directly into the clipboard so that you can use it in OpenAI's Canvas or Cursor. So let's get into it. We're over in ChatGPT, and I'm going to select GPT-4o with Canvas. Now at first it'll look the same as the other models, but as soon as we type prompt and press enter, things will change. So here's our starting prompt. Firstly, you're going to help me process a Ruby inspired DSL structure to JSON. There'll be two parts to what we're doing here. There'll be part one where we're just going to work with a simple reflection based technique, and then part two, which we may do, which will be about converting it into an AST technique. And lastly, to get started, I'm going to give you some example DSLs and let's see what it can do. So it said, sounds good, and it's waiting for the first Ruby DSL. So what I'm going to do is paste in the code that we were just looking at earlier, and you can see things start to change around. We've got code concepts going on the right, we've got conversation going on the left. And the code conversations that it's done is as per the request that I made in the chat window. Can you convert that data structure into a hash format, which is very similar to a JSON format? Now I'll just bring up the code that we copied, and you can see it down the bottom here, and it's looking exactly the same, only in this new format. So let's move on to the other one we've got, which is called the build prompt. And I'm just going to come over to the chat and paste that one in and see what happens. So it's going through the old hash format that was there, and now it's building a new one. So it can understand converting the Ruby DSL structure into a Ruby hash structure. Hopefully when we get to writing code, this will be a pretty simple process. Now, if you're interested in seeing how I process files using prompts, you might want to check out the video I did recently on processing a Git diff with 1,000 files, about 2,000 changes. And I was essentially looking for a particular issue in the code and then using a prompt on those found issues to generate new code using CursorAI. I have this DSL which I use for GPT agent workflows, and the particular workflow is how I release my videos. There's all sorts of prompts that I do. There's sections and steps that I do around the thumbnail, the title, the LinkedIn post, etc. And all of this information happens to live in a domain-specific language. So we'll just copy that information and we'll come back to ChatGPT Canvas and paste it all in and see what it reads out of that. Now, this is quite a complex file coming through. So it scans through the original files, and then we're going into this concept called a GPT agent workflow. We got the description of it, we got the different prompts that it's reading, we got the sections, the name of a section. So this is the video preparation where I'll configure some data and then I'll write the script, the abridgment, I'll do some QA work. So all of this information is coming together and it's finished. I think we'll do one more example. Imagine you had a dream sequence video with a whole lot of prompts that you turned into images using something like MidJourney or Leonardo. Well, that's exactly what I've done in the past. There's a video up above, but here it is, Storyboard graphics, and it's called the dream sequence in this case, and generate image prompts from a video transcript, and you would supply the transcript file. From there, give it some sort of design that you want, and then write out a prompt CSV file and send it to a particular API, maybe Flux One or MidJourney. So what we'll do is we'll copy that information and we'll just paste it in and let the last bit of information come into the system. Next, we're going to start writing a bit of code. Here's the prompt that I wrote. Now, I did it using my voice. There's some grammatical errors, but basically it's just saying, here are the files that we're going to work with. They're based on the files that it's already been looking at. I've said that it needs to create a little tool that uses reflection-based approach to read those files and convert them into a JSON format. One of the things that I've told it is that there might be issues with positional parameters, because the idea is that the method name and the named parameters would make up the attribute names and the node names within the JSON document, but sometimes you don't actually have a value. I think I have an example here. So if we look at the YouTube optimizer, you can see here that there's a node called input, but there's no actual name. We don't know what parameters coming in on this case. Same with the section and the step title. We've got to allow it to figure out what to do in that situation, and then I've just listed the files that we want. Now we're back over at ChatGPT Canvas and we'll just paste in all that information and let's see what it comes up with. So it says, to accomplish part one of the system writing reflection based tool that reads the DSL file. I'm not even going to read that. A whole lot of stuff is going on and it's starting to write an application called DSL Parser, and it looks like it's going to store the internal structure within a hash. The key point that I think we need to look for is that it has a method missing going on. So essentially it's going to interpret the Ruby code and it doesn't know the method, but it'll interpret that and turn it into data. So let's test it out. What I'm going to do is just copy all this information and we'll head over to Visual Studio and I'm just going to paste it in there. Now there's additional parsing down the bottom, but what we'll do is I'll just manually massage it a little bit. The main thing I want to do is print it out and also write it out as JSON. Now here is the file I want to parse first. I've put a little terminal window down the bottom so we should see things come through, and I'm just going to hit save on that, and we've got what looks to be JSON coming down. And if we just click in over here, we can see the same information. Let's just pop that over here and it should match. So here we got context gatherer, definitely got that. Files include, we've got prems lib architecture. So look at that, it didn't quite work. It didn't get the concept of multiples, which makes a whole lot of sense. It doesn't know how to deal with an array of types, but it got the exclude and it got the actions, and it seems like all the information has come through here. Now we'll move on to the build prompt example. I'm assuming it's going to have the same problem here, of course, and if we click on that, it's created a JSON file, and if we move it over to the left, We can see we've got the context gatherer within the build prompt. We've got files, but we've only got one listed. But everything within the prompt should come through because they're just single nodes going on. The way I use this third one is interesting. We've got the Storyboard DSL going on, and I would send this to a tool that I have that reads in the transcript file. It applies a bit of stylistic design that we might want and generates visualization prompts. From that, they're written out to a CSV file and finally sent to a platform. And the way that can look is on a video that I've got here. We can see the graphics are just being transformed using CapCut in this particular case, and we get nice visualization that allows us to do a story around, in this case, the ClueLess programming language. The clue is to do less. And that video can be found over on the AI TLDR channel that I have. It's just here. I just released it recently. And if you want to find out more, please check it out. So let's look at the last one. It's got a really interesting use case that I currently put it through. Now, it's got the same problems that we've seen. If we look at the prompts here, there's only going to be one listed, but pretty much all the other data is starting to come through okay. And what I tend to do is I like to write my agents as code using DSLs. And as soon as I've written a schema object that allows me to make sure that it can deal with arrays, different type definitions, and other sorts of rules, what I can then do is hook that information directly up to a web application, being the agent workflow. And in this is just a case of prompts with merge capabilities for various variables so that you can generate prompts dynamically in a workflow sort of system. And the good thing about it is that you can have various phases in the workflow and all of it's generated directly from the DSL. Well, there we have OpenAI's Canvas, which I think was an amazing experience. I only tried it and thought, wow, this is really cool. If you're interested in what I'm doing with the ClueLess programming language or the Agent Workflow Builder, there'll be a link in the description. If on the other hand you just want to learn more about prompt engineering or coding with AI, the next video that I'm going to talk about is creating documentation for AI pair programmers. I'm Happy Dave. Please like and subscribe, and I'll see you in the next video.